Hello and welcome. We're going to talk in this chapter about network access. We're going to talk about let's leave media alone and go into this next section on data link layer protocols. The data link layer sits right above the physical, and again, the data link is what connects the physical activity of energy and ones and zeros coming into a computer. The data link works both with the energy signals and the logic, so it converts it to the logical side of computing. Every data link layer puts on the MAC address. The MAC address is a layer 2 address. So every frame has to have a source and destination MAC address to go along with the layer 3 IP packet. So remember, layer 2 is MAC, layer 3 is network addressing, IP addressing. So, underneath the data link layer, there's a MAC sublayer, and this is the part I was talking about that handles the signaling and converts the signaling into the LLC stands for Logic Link Control. So it takes the physical and converts it and links it to the logical side of computing. You heard me use the term media independent. So when Paris talks to Japan, there are many different types of media that get involved in carrying that frame from end to end. And every hop along the way, the MAC address has to change, because the MAC address is the MAC address on this computer sending it to the MAC address on this router. And then it changes from the MAC address on this router to the MAC address on the satellite, vice versa, switches, skips, hops, down to where this computer's MAC address goes on and recognizes this PC's MAC address to send the frame. And inside those frames are the IP packets and addressing and the data. So the data link layer brings frames across the web and into the computer for use. And again, different standards, IEEE standards, ISO, ITU, and ANSI, those are all the working groups that put together these standards. So in this last section, talking about media access control, we have to know the rules. We talked earlier about communication rules in the first chapter. Now we need to know how to share media. Now, before switches, everyone shared the same frame and they would collide all the time. But now we have switches that segment the layers, and micro-segmenting it's called, when a PC plugs directly into a switch, so that PCs and other devices aren't competing for that bandwidth on the wire and having collisions. But with hub environments, they still do. All right. But there are rules for going out, and CSMA, CSMA-CD, collision avoidance and collision detection are the rules that they use to keep away from each other on the web and not have too many collisions, because when frames collide with each other on a wire, that collision of energy disrupts the ones and zero signaling, and the receiving computer has no idea what to make of it, and so it eventually has to be resent by the computer. So again, physical and logical. The physical topologies are the way that the computers are actually laid out and the wiring scheme, and the logical talks about who has access to what. Which network address, IP address is logical, different groups within inside the physical topology. A couple of common topologies you need to know: point-to-point, device-to-device. Hub and spoke, this is most common in most work environments. Everybody plugs into a central switch. And full mesh is referred to, but you won't see it very often. That's kind of a pricey way to do it. Point-to-point technology is router A to router B, and it can go, via the cloud, which is the network of telco network. It's generally given a cloud shape because we don't get to know what's in it. We can't see through it. We just know that we're using a serial interface from one to the other going through the ISP. But that is point-to-point. It's not for any others to see. So it goes from the source to the destination on the same link, on a logical point-to-point. Now we say logical because there is some switching that happens in the cloud, but we are not involved in that. And there's that switching in the cloud that I talked about. So logical point to point. So here's a star topology, generally with a switch, what used to be a hub in the middle. Extended star. Now the bus topology pretty much gone. This used to be the old Ethernet cable and the signals would run up and down. And the token ring topology, these are very much legacy. They're still accommodated and can run, but it's pretty slow and pretty outdated. And wireless is really replacing anything that would need something like that. Now, duplex is a term you'll need to understand in the settings of communication. Half duplex and full duplex. And to clarify those terms, when I can send a message or receive a message, but I can't do both at one time, that's half duplex. Full duplex happens when I can send and receive at the same time. So obviously your higher speed links are going to run in full duplex. Now we saw that the fiber cable came in pairs. One was for sending, one was for receiving. So fiber always runs in full duplex mode. Cables, when they get up to the 1,000 gigabit speed, that, they have to be in full duplex. So they're using all 4 wire pairs. Normally, in regular Cat5 communication, it's just two of the 4 pair are busy, traveling and working in half duplex. But by enabling all 4 pairs, full duplex is possible. Many of the devices auto-sense full or half duplex and configure it for you with an MDIX protocol. But it's good to know what they are. Now, media access control, this is contention-based, where CSMA-CD, collision detection, is where if 2 frames do collide, and this is on a hub, and again, we don't see many hubs anymore. This problem has largely gone away. But in legacy setups, you'll see where there's a hub, and on a hub, everybody hears everything that everyone's talking about, and those frames collide. So that's contention-based. So if there is a collision, the computers know it, and then they back off to a random, what's called a back-off algorithm, and they do a random delay to resend the signal. The old token ring network, this was 90s. It kind of went out of date, but you'll still see some in old places, especially government agencies and what have you. That topology, there is not a physical, but a logical energy token went around and around 20,000 times a second looking for data to carry around. But again, this is pretty much gone. So CSMA-CD, medium's available, so he sends a frame. They're listening and sending. That's collision detection. There's also collision avoidance. All right. Here's, and you can see in these examples that they had to contend with the hub with a switch, and now that the cost of switches is so far down, this really isn't an issue. Collision detection, if you microsegment the network, then it's not a problem. Now, that's true on cabling. With Wi-Fi, collision avoidance, CSMA-CA, the collision avoidance access is where it's listening, constantly listening to the signaling, and says, oh, it's busy, I'm going to wait. It has to sample and see if there's room to send on the wireless frame. So if this guy's receiving a wireless frame, these other 2 get that frame. They see it because they're in the same area, and so because somebody's getting a frame, they have to wait to send theirs. And that can be why Wi-Fi has a lot of contention and access issues. Now the data link frame has a header, data, and trailer, and here it is, the start frame, and then there's the addressing. All right, there's the frame, which would be MAC address, and then there's control data for the type, and then the packet data fits in here, and then there's an error detection, and then a frame stop, or a CRCD, which is a redundancy check, and it makes sure that all of the frame is in there, that the number of bits sent was the amount received. And again, the source and destination MAC addresses fit into that frame, and they change at every device. The L2 the L2 address is different between all of these. You can see that's represented by the colors. Now, once again, NIC addresses are going to change at every device. That's very important. But inside, the source and destination IP never changed. The MAC address gets taken off at every device, and a new MAC address gets put on, but the source and destination IP address stay the same. So different types of frames that you'll hear about while you're studying the wireless frames, the 802.11 standard, PPP or point-to-point protocol frames, HDLC, which is standard on Cisco routers and switches. Frame relay, kind of pretty much gone, but we still might talk about it in the next course. And then Ethernet frames. So there you go, this series of little videos, and you should be good to go for the chapter. We'll see you soon.